Hey guys, welcome back. In this video, I'm going to teach you how to integrate partial fractions, and it's actually really simple. So right now, the most important thing for me, or in my opinion, is how to integrate 1 over x to the first power. We know that 1 over x to the first power is always the natural log of x. I like to avoid u substitutions, and I can do that in this way. The integral of 1 over x minus 7 is natural log of x minus 7. You're going to take the derivative of x minus 7 and divide by that derivative. In this case, it's just 1. The reason why I'm doing that is so I can avoid u substitution. In this case here, the integral of 1 over 2x plus 3 is natural log of 2x plus 3. Okay? The derivative of 2x plus 3 is 2. I'm going to divide by 2, so that's 1/2, plus c, of course. I just avoided doing a full u substitution. Anytime you have 1 over x to the first with any number in front of it, it's going to be a natural log, and then you're going to divide by the derivative of the, basically the base of the natural log. So let's take a look at another one. In this case here, I have 4 over x plus 2. The integral is going to be 4 natural log x plus 2. I always put bracket absolute value signs around it. Here I have 4 over the natural log of 3x plus 1 plus c. You're going to take the derivative of 3x plus 1, which is 3, and you're going to divide by it. Great. So what we're going to do in this case, we're going to actually leave this like this, but if you really want to change this, we know there's going to be a few properties, and I'll probably just do it in the next example, but there's a few properties that we're going to need if you want to write natural log or your answer as one term. So let's take a look. All right, here's our first example about partial fractions. First and foremost, the integral of 1 over x squared minus 1 dx cannot be integrated. So what I'm going to do is I'm going to write 1 over x squared minus 1 as some number over one of the factors of x minus 1 plus one of the numbers, or a number b, over x plus 1, the other factor. In other words, I know that this is the same thing as x minus 1, x plus 1, and I'm going to try to figure out what to put if I try to separate this. So I'm going to do a over x minus 1 plus b over x plus 1 equals basically my question, which is this. I need to solve for a and b. Okay? So what I'm going to do is I'm going to get rid of the denominator. I'm going to do crisscross without the tomato sauce. So I'm going to go a times x plus 1 plus b times x minus 1. And that's just going to equal to the numerator. Now you guys can cancel fractions any way you want to. I like to do it this way. So it's basically crisscross without the tomato sauce, without the denominator. Let's get rid of one of the variables. So I'm going to set x equal to positive 1. When x equals positive 1, I get a times 1 plus 1 plus b times 1 minus 1 is equal to 1. The reason why I chose x equals 1 is because I needed to put something in here to get rid of that. That way I can get a 0 and solve for a. This says 2a plus 0 equals 1. Therefore, a is equal to 1 over 2. Great. Let's figure out how to get rid of the a by plugging in a value for x. That way we can solve for b. So what I'm going to do here is I'm going to set -1 to x. And I'm going to go back to here. And I'm going to figure out what b is. So I got a times -1 plus 1 plus b times -1 minus 1, which is -2, equals 1. That's 0. b is equal to -1/2. So I got a to be positive 1/2, and I got b to equal -1/2. So I go back to my question up here, and I'm going to rewrite it. If you solve for a and you solve for b, then those numbers must go on top of the a and the b. You cannot swap them. So in other words, 1/2 must go on top of x minus 1, and negative 1/2 must go on top of x plus 1. Okay? So I'm going to erase some of this, and watch how easy this is now. So I'm going to have 1/2 over x minus 1, and I hate writing fractions like that, minus 1/2 over x plus 1. All of this is with dx. Okay? So now I can get rid of this. So the integral is natural log of x minus 1, natural log of x plus 1. Right, everyone? What you can do is something so amazing. You can actually say, this is the natural log of x minus 1 over x plus 1, all raised to the 1/2. Why? Because you could pull out the half if you wanted to, rewrite x minus 1, remember our properties? The natural log of x minus 1 minus the natural log of x plus 1 ends up becoming a division. And then the half from the front ends up becoming the exponent. So you want to look out for those. Let's try another example. 5 over x squared plus 7x plus 10, well, I don't have a perfect u sub. The bottom looks factorable, so why not? Let's see what we can do. Let's create two fractions. So I did I did a over x plus 2 plus b over x plus 5, which are the two factors for this. Okay, equals the question. Chris, do not distribute, cross, do not distribute, tomato sauce. Just the 5, there's no tomato sauce. We're gonna just stick with the tops. All right, so how am I gonna get rid of this? I'm gonna need negative 5, and that would get rid of this person. And I'm gonna need a negative 2, and that would get rid of that person. So let's do one at a time so we don't get rid of everything. So you're gonna get a times 0 plus b times negative 5 plus 2 equals 5. Negative 3b equals 5, and therefore b is equal to 5 over negative 3. Okay, now let's plug in negative 2. So that gives me a times 3, when you plug in negative 2 into this, plus b times 0, that was our point, equals 5. So therefore, a is equal to 5 over 3. Okay? So I got a to be 5 over 3 and b to be negative 5 over 3. So let me get rid of this. I don't want to mess up. So those are my a's and b's. Let me hold off. So a is 5/3 over, right? B is negative 5/3 over, I'm sorry, that's going to be x plus 5, because that. And now we're just going to integrate. Forget about the coefficient, 5/3. This is going to be 5/3 natural log x plus 2 minus 5/3 natural log x plus 5 plus c, of course. You get 5/3 natural log x plus 2 over x plus 5, and then you could raise that to the 5/3 power. I'm only doing this in this way because a lot of times the AP doesn't have it spread out or expanded like this. Sometimes it's this raised to the 5/3 power. So this is perfectly fine, but just in case, I want you to understand it disguised. Okay, so that's how you do that. I'm gonna do one more problem and then I'm done. Okay, this problem is really important because in this last problem, it was just 5. In the last problem, it was just 1, and so on. Here, it's 4x plus 5. So I took this problem here. U sub actually does work. I just saw that right now. Wow. Okay. I don't care that it works. U sub does work. You guys should do U sub just to see it and see if our answers match. Okay? All right. So A times 2x minus 1 plus b times x plus 3 without the tomato sauce. I'm going to make x equal to -3 so I can get rid of this. So that's going to be a times -7, because don't skip steps, okay? 2 times -3 is -6, minus 1 is -7. And I'm going to get -12 plus 5, which is also -7. So a is equal to +1. So I'm just going to go right up here, and I'm going to put +1 here. Let's solve for b. I'm going to have to put a half, right? 2 times a half, so x equals a half. So 2 times a half is 1, minus 1 is 0. And then I'm going to have b times 1/2 plus 3. Well, 1/2 plus 3 is really 7/2, okay? And now I'm going to put 1/2 here. So 1/2 times 4 is 2, that's 7. If you divide 7 divided by 7/2, well, 7 divided by 7/2 is keep, change, flip, and you get the number to be 2. So this is going to be 2. So I hope everybody sees that. Let's take a look at the integral. The integral of 1 over x plus 3, I'll just do dx, plus 2 over 2x minus 1 dx. So natural log of x plus 3, the derivative of x plus 3 is 1, so you divide by 1, 2. Natural log of 2x minus 1, the derivative of 2x minus 1 is 2, so you got to divide by 2. And so you get natural log of x plus 3 plus natural log of 2x minus 1 plus c. So everyone, that's how you integrate partial fractions. You basically get them down to a over one of the factors, any factor, plus b over the other factor. You solve for a, you solve for b, and it always leads into a natural log as long as it's x to the first power. Have a great day.